Hello, this is Professor Baswhite. Today we will look at some applications of trigonometry, mainly arc length, angular velocity, and calculating areas of segments. So I'll give you some formulas and you'll just end up calculating these, and they are fairly simple to do. So let's get started with the arc length. What an arc length is, if you think of a circle, and here's the center of the circle, and you take a segment and you have an angle here, and excuse me, this is the length that we are talking about, the curvy length in there, and we will call it S. And that is simply, since it's, beginning trigonometry, you don't need to know where that comes from right now. And if I have a radius r, the arc length formula is r times theta. Now what's important is that the units. So if you enter feet as your radius, you're going to end up in feet as your arc length. And this theta is supposed to be always in radians. And then if somebody gives you the degree, always convert it to radians before you multiply. If this is meters, this is going to end up meters. Okay, so, and the other thing that you need to know, if somebody gives you degrees, you know that 180 degrees is pi radians. So they give you the degrees. Let's say they're giving you 30 degrees. And you go, okay, how much is 30 degrees x radians? You already know it's pi over 6, but let me show you. You crisscross. And then you go 180 times x equals 30 times pi. You divide both sides by 180. And then the 180s go. X equals 30 divided by 30 is 1. 180 divided by 30 is 6. Pi over 6. So let's try to calculate the arc length of a segment when theta is 30 degrees and the radius is 2 meters. So the first thing you do is the conversion. So I have the theta is pi over 6 radians. Then your S is going to be r times theta, which is 2 times pi over 6. Simplify it. 2 divided by 2 is 1. 6 divided by 2 is 3. Pi over 3, what are the units? Since I started with meters, the unit is meters. Fairly easy. So let's go to the next one. The next concept is linear velocity. Right? Now, again, if you have a circle, you have the center, you have the radius, you have the angle. The linear velocity, v, is the arc length divided by time elapsed. So you go and you calculate your arc length, which happens to be r times theta divided by time. So let's say somebody says, and then in terms of units, if this is in length, let's say meters, and this is minutes, and radians doesn't come in the pictures like unitless, so your velocity is going to end up meters per minute. And if you have, for example, feet, and you have second, your velocity is going to end up with feet per second. So you have to be consistent, that's all. So let me actually write this in red because it's hard to see it in green. All right. Now, so let's go and do a problem. Let's say I have a wheel, radius 3 inches, and it rotates 5 pi over 6 radians in 3 seconds. Okay, great. So your velocity is s over t. Your s is r times theta, so r is 3, and theta is 5 pi over 6. And your time is 3 goes, so you end up with 5 pi over 6. What are the units? You have inches, because radius is in inches, per second. Okay, let's go to the next concept. That one is angular velocity. And it's given as omega, and that's the angle divided by time. How many degrees or how many radians did you travel in a certain amount of time? And again, you have your circle, you have your r, you travel theta. Your angular velocity is going to be how many degrees or radians you traveled divided by how long it took you. Okay, usually it's given in radians. And the time is in minutes, hours, seconds, or whatever that they are giving you. And then your angular velocity is going to be radian per whatever the time unit you have in there. Okay, now what is the relationship between the linear velocity and angular velocity? Remember, the linear velocity was, it has some length in it. So I need the length in the linear velocity. In omega, I only have the radians. So to go from the angular velocity to linear velocity, all you have to do is multiply the angular velocity by r. So let's say a wheel is turning 3 times in 6 seconds. All right, and they're asking, what is the angular velocity? What's the linear velocity? Okay, what does that mean? 3 times. One time it goes around, that's 2 pi radians. So the excuse me. So it's going to go around 3 times. You're going to have a theta of 3 times 2 pi. So it traveled 6 pi radians in how many seconds? 6 seconds. So if I want to calculate the linear velocity, all I have to do is take my theta, which is 6 pi, and divide it by 6 seconds. These go. What is the angular velocity? Pi radians per second. If I want to convert this to linear velocity, what do I need to do? I need to multiply it by the radius, and let's get a radius of, did I give that? Let's say that wheel has a radius of 5 inches. So what do you need to do? 5 inches times pi. What are the units? 5 pi inches per second. All right, so let's save this so that we don't lose it. The last concept is area of a sector. So let me explain that. Okay, this is what we're talking about. Your unit, your circle, your theta, your r. The area, this area, is going to have this formula, theta over 2 r squared. Okay, so let's say I have a theta of 2 radians, let's use the capital R. And I have a radius of 7 centimeters. The area of that red area, it doesn't matter, it's not to scale, is simply going to be A equals theta, which is 2, divided by 2. R is 7, and square. So it's 49. What are the units? Since R was input as centimeter, so the area is going to be centimeters square. So this concludes some applications of trigonometry involving wheels turning and arc length and areas and sectors and things like that.